Hi, everyone. I'm super excited to be here. My name is Luis Massen. I'm the Director of TechOps Analytics at United Airlines. I lead an embedded analytics organization of brilliant data professionals in the operation. And we get to work with the frontline, with our frontline leadership, and with back office folks across the entire range of analytics, from descriptive, diagnostic, predictive, and prescriptive. So thank you, Palantir, for the opportunity to talk a little bit about our predictive maintenance journey today. Some of you might not know that United, by most accounts, is now the biggest airline in the world. We have a diverse fleet of almost 1,000 aircraft to manage across the world in real time. So delivering a customer experience depends on uptime of that equipment, and TechOps' mission is to deliver safe and reliable, customer-pleasing aircraft, facilities, and ground service equipment to our business. Together with Palantir, we built the log page object in 2018, which is millions of records of technician write-ups since 2016. And this enabled our data scientists, analysts, and even frontline leaders to get actionable insights about what's happening in the business. This also created a compounding data asset that formed the basis of our predictive maintenance capability, our true predictive maintenance capability. This is a real view of the log page object in Foundry and all the analyses that it's enabled. I'm really excited to bring you one of our recent wins on Wi-Fi predictive maintenance, elevating the in-flight experience with data-driven insights. This strategy focuses on integrating the diverse data sets to process vast amounts of information and ultimately powering a state-of-the-art Wi-Fi health monitoring system. So each flight, our Wi-Fi is sending us heartbeats every 5 minutes. So we get, on average, 38 heartbeats per flight on 2,600 flights per day. This is a huge data set of almost 100,000 heartbeats per day and 36 million heartbeats annually. This comprehensive monitoring allows us to proactively identify and swiftly address connectivity issues to enhance the overall in-flight experience of our passengers. So this is an example. For instance, when a potential issue was detected on one of our aircraft, our system immediately flagged the anomaly. The rapid response system involved replacing a faulty component, which was reflected in the subsequent stabilization of our Wi-Fi health score. This shows us the capability to maintain high standards of reliability and passenger satisfaction with prompt issue resolution. Now, this is a historical event, but we're doing this as we speak in real time. The other thing to note is in this instance, we removed and replaced a Wi-Fi antenna. And you can see the time series stabilized, so we know that we have an effective fix on that aircraft immediately. In the previous paradigm, we would have to wait, sometimes weeks, to make sure that that fix was effective and make sure that the issue didn't recur. The other thing I think that's fascinating about this is traditional predictive maintenance uses sensor data coming from the aircraft, operational data for operational purposes. But this is actually coming from our commercial contracts, the commercial side of the business. So we have Foundry across the enterprise, and we're able to leverage data sets from across the enterprise, and our data scientists can pick out a predictive signal from anywhere they can find it. So we deployed Chime late last year, and already we're seeing huge benefits. We've already saved almost 300 delays, 20 cancellations, and this represents millions of dollars of cost avoidance and a better passenger experience. So far, we've saved over 100,000 customers from delays and cancellations. And if you can't feel it, we're currently in summer. This is our peak travel season, so this number is only going to go up. This is a look ahead, but really it's what's happening now. What we're looking into is intelligent servicing. So currently my car sends me alerts whenever it needs new oil or a new filter. Our aircraft do that too. But due to a legacy of regulatory requirements, we're not able to leverage that information to be proactive and surgical in fixing what's wrong with the aircraft. We have to do repetitive maintenance tasks over a series of time that waste labor and induce cost. But we're working with our regulators to shift that paradigm to something where we can leverage the data that we have available to us to do exactly what the aircraft needs in the moment. Secondly, technician recommendations. We have a huge, unprecedented inflow of new technicians. A significant portion of our technician population is below 5 years of experience. So how can we leverage the experience that we have in our data assets to spread that across all of our technician population and deliver insights directly in their workflow? They have iPads. We should be able to push those predictions directly into their iPads. Finally, adaptive and active learning. So COVID completely changed the aviation industry, the airline industry. What we do now is completely different than what we've done in the past. And I expect that that will continue. The operation is dynamic and constantly evolving. So how can we make sure that our models do the same? Thank you for your time. A sincere thank you to Palantir for their partnership. And I can't wait to talk to you all a little bit more about predictive maintenance and how we're pushing the boundaries at United.